Hey guys, welcome to our video for regression. Now, this is going to be a little different. I'm not at the chalkboard, and the reason why is because this entire process is going to be done in your calculator. So I want to show you all of those steps rather than holding my calculator up to the screen. We're going to do some screen sharing, and I want to talk about some stuff here real quick. So in our Blackboard, in our My Open Math page, when you look down at function regression, you'll see there's actually three different things. The video's not up because I'm making that right now. There's three different links here, okay? The first one here says video guide, and what this really is this is just the activity that would be done in class, and this is what we're gonna be going through in the lecture, okay? So we're gonna be talking about a few things, and then we'll be going through and doing some of these problems. This next piece here, the function regression steps, this is a really important one. If you are somebody who likes to have things printed out and have them in front of you, or if you wanna rewrite things, this is a really big one. These are the steps that we're going to follow to set our calculator up, and then what we're going to do every single time to work our calculator. Okay. It also has a table describing each of the different types of regression that are in your how they appear in your calculator, what their name is, and then what the equation it gives you looks like. Okay. So we're going to talk about those. And the last one, this function regression, is kind of the video quiz, I guess, if you would guide. It just kind of has, so if you want to do minimal stuff, what are the steps to doing regression on your calculator? And then what is the range for R squared and what does it tell you? Okay, so those are really the two big things to take away. So R squared is something we'll talk about in just a minute. So let's go to our steps first. The first thing we have to do is we have to get our calculator set up in the correct manner. And to do that, we have to turn on the diagnostics, is what it's called in your calculator. And this is going to give us the correlation coefficient R squared. Okay. It only occurs when you perform linear, logarithmic, power, quadratic, or exponential regressions. It doesn't show up when you do this last one, logistic. And so this number here, R squared, this correlation coefficient, is really important. Okay, it measures how well the equation we've created, our calculator's created, fits the data it was given. And in particular, it ranges from 0 to 1, including 0 and including 1. So if you want to put that in interval notation, bracket 0, comma 1, bracket. Okay. If it has, the closer to 1 the correlation coefficient is, the better fit the data has. If it is a 1, that means it fits the data perfectly. So if you were to give it 2 points and say find the equation of a line, do linear regression, it's going to be able to fit an exact line perfectly through those 2 points. So you're going to have a correlation coefficient of 1. And that means it exactly perfectly fits. Now, a correlation coefficient of 0 means there's absolutely no correlation between the equation and the data given. Typically, what that might look like is if you just say have like a shotgun blast of points, just a big smattering all over the place with no, let's say it's almost like a circle, a filled-in circle of all these points. It really doesn't have a linear format or a quadratic or an exponential. And so you might get some really bad values. It's really hard to get a score of 0. It's easier to get 1 because things typically fall in a pattern, especially the things I'm going to give you are going to fall into something. And so that's something, the first thing you want to do is to get this. It's really simple. You only have to do this once unless your calculator completely resets. Okay. You're going to do second, then 0. Okay, so let's get the calculator up here. So I'm going to work on, this is a T84 Plus Silver Edition, but it's the same on all of them. So you're going to hit second, okay, and then you're going to hit 0, because what we're getting into is this catalog. The catalog is basically the listing of all of the built-in functions that our calculator has. Now, we need to go to diagnostic on. Now, there's a couple ways you can do this. You could just hold the down arrow and scroll down, okay, but we know it starts with a D. So if you hit the alpha button and then hit the x to the -1 button, which has that little letter D there, it'll just automatically, we hit alpha and then D, it'll automatically jump to the D's, and then you can just scroll down till you get to diagnostic on. Now let me shrink my face so you guys can see that better. So once you're down to diagnostic on, all you're going to do is hit enter and then enter again. And so your screen should say diagnostic on, done. That's it. This is turn that on. You don't have to do this again. This isn't something you have to do every problem. It's the only time you should have to ever redo this is if your calculator battery dies and it completely resets itself, or if somehow you manage to turn this off. And you'll know that because it won't give you the R squared value. So if you do your regression and it doesn't give you an R squared value, you need to go back and do this step, turn on regression, turn on diagnostic. Okay, so let's go back to our browser here. So once we have that done, the next thing to do is enter your data. Okay, so let's look at this first problem. So in this was the function regression video guide. Okay, and we're going to look at this first one here. So for this activity, so this is something that if you were in class with me, this would be something we would be doing in class, and you'd be working in groups doing this. However, we are in class. So make a scatter plot, fill in the table that's referring to this table here, choose the best one, and then using the best function, answer any questions stated in the problem. So our problem says, as Earth's population continues to grow, the solid waste generated by the population grows with it. Governments must plan for disposal and recycling of ever-growing amounts of solid waste, garbage. Planners can use data from the past to predict the future waste generation and plan for enough facilities for disposing of and recycling waste. Given the following data on the waste generated in Florida from 1990 to 1994, predict the average tons of waste in the years 2000 and 2005. Use number of years since 1990 as the input. This piece right here is really important, okay? Anytime you are dealing with a problem, a data set that has the year as the input, so time is pretty much always inputs, right? The passage of time. If it's things like how long you waited in line, that's different. But this right here is always going to be the input. You never, I repeat, never use the actual year as that year, okay? So you would never enter your data as 1990. And the reason why is because there's no numerical significance to 1990. The significance is that's kind of the start point. And so when we think 1990 of the year, we're like, oh yeah, that's the year 1990. But when our calculators see it, they think, oh, that's the number 1990. So we always will re-index the years. And so in this problem here, we're using years since 1990. So when we go to enter our data, our X values are going to be 0, 1, 2, 3, and 4. That's going to be our inputs. Okay, not 1990, 1991, 1992, 93, 94, but 0, 1, 2, 3, 4. Okay, always. All right. If it doesn't say to re-index the years, you can kind of choose what you want. For the most part, I usually specify. I think there is one problem. Let me see here. Yeah, so I specify in all of these, so you don't have to worry about it. I also, on the homework and any test or anything like that, I will specify all of those. So let's talk about how to enter our data. It's really simple, okay? You're going to go to Stat, Edit, and then press 1, okay? So that sounds like a lot of steps, but it's not. Stat, you're already in the Edit menu, so you just want to hit Option 1 or Enter. So really, all you're going to do to enter your data is you just hit Stat, Enter. That's it. And now you get this list menu here. You've got list 1, list 2, list 3, and so forth. Okay. Now I've got numbers here in my list 1 because I've been doing things in here. I want to get rid of them. There's a couple ways I can do that. If I wanted to get rid of just a single term, say I like, oh man, I didn't mean to type that, I need to get rid of it. You could just highlight it and hit delete and it goes away. But if I want to get rid of all of these and I don't want to hit delete on all of them, I can go up and highlight the list name and say, okay, I want to clear this list, and then just hit enter. That's it. Now let's say you have a brain vacation moment, your brain is gone, and you highlight the list and say delete list. Oh no. Now where's my list 1? It's not there. Oh no. If you look here, okay, under 2B, it says if you don't see columns L1 or L2, press Stat and select option number 5, Setup Editor, and then hit enter. Okay. So you're just going to go, okay, I don't see list 1. I accidentally deleted it. Oh my gosh. You're going to go Stat on option number 5, Setup Editor. Now, it should be all the same for everyone's calculator, even 83s and stuff like that. But if yours is different, make sure it's Setup Editor is the option you want. Hit enter, and then enter again, just like we did with diagnostic on. Once you see that Setup Editor done, that means it's been done. Go back to Stat, go back to Edit, and I see L1's back. Okay. If you accidentally deleted the list and you had numbers in there, when you set up editor, the numbers will still be there. Okay, you just deleted it from this screen. You didn't actually delete it out of your calculator. Okay, so now how do we enter your data? Well, very simply, we always want to enter our data into columns L1 and L2. In particular, we want the inputs to be L1 and the outputs to be L2. The reason we want to do L1 and L2 and inputs, outputs is because that's what our calculator will default to. If we do things in, say, L3, L4, or backwards, outputs in L1, inputs in L2, we're going to have to change things later on. Whereas here, we can just use the default and it makes our life a lot easier. So for that first problem, our inputs are 0, 1, 2, 3, and 4. Now just press over to get to L2. Now for this one, we need to look at this. So 19,358. 9, 8. Luckily for you guys, your calculator is in front of you, so you don't have to go back and forth in tabs. So 19,484. 2293. 21,499. And 23,561. All right. So once you're done entering your data, a quick check will kind of help alleviate some headaches along the lines. Make sure your two columns line up. Make sure that these both match. One of the most common things is, especially on a list that's like 0, 1, 2, 3, 4, when you're typing it in with your hand, okay, it can be very easy to accidentally think you hit the enter but mishit it, or didn't register, and so you get a row that's, say, 34 instead of 3 and 4. And then we go like, wait, oh, hey, these don't match up. And then you can go back, you're like, oh, silly me. I want 3 and then 4, not 34. Okay, so you want to get this all done. Now from here, you can just jump into the next step, or if you want to, you can hit second and then mode, and that'll quit you back to your home screen. Okay, so step 1, we did that. Remember, that's only one time you have to do that. You don't have to continuously do it. Step 2, our data has been entered. Now, step 3, it says enter independent variables in L1 and dependent variables in L2. So step 1, 2, and 3 done. Now we want to get a scatter plot. We want to look at what this data looks like, because it's really important to look at the data and see, okay, does this look like it's curving up? Does it look like it's just going straight? Does it, what's the shape of this look like? Because we can look at that, and with our experience with all of these different functions, we can go like, oh, hey, that kind of looks like it might be like a quadratic or maybe an exponential. It's definitely going up, so that's going to have a positive a value if it's a quadratic. It's going to be exponential growth if it's an exponential. We can identify all of these things just by looking at the shape of the data. We don't have to always use the regression to give us all of that kind of little simple information. To get the specific numbers, we're going to use the regression. So let's get the scatter plot. This, again, is something that's going to be kind of a one-time setup, and then we can just turn it on and off really easy. Okay, so the first time you're doing this, you want to hit second and y equals, because we want to make sure this is set up the way we want it. Okay, and we have different stat plots. So you have 1, 2, and 3. So we're just going to choose stat plot 1, just hit enter. Okay, you can turn them on and off through here just by kind of doing like this, on or off. When you go to type, you're going to hit down to get to type. And then if I wanted to do a different one, I just have to use the left and right arrows to cycle through. Okay. But I want it on this first one here, because this is a scatter plot. So if you happen to have, say, a histogram like this selected, okay, you would just scroll back to the scatter plot, hit enter. Now notice, if you hit down, our X list is L1 and our Y list is L2. It defaults to that, right? So remember, this is where it's beneficial to use those L1 and L2 for your inputs and outputs, so you don't have to go back in and manually change this all the time. Marks, it's just kind of the way the dot is shown on the screen. Doesn't really matter, okay? So this is now set up the way I want it. It should be like this for you guys starting out. It shouldn't be anything to change unless you've changed it already. So now I'm going to quit. So now I'm going to show you how to quickly and easily turn this on and off. So let's go to y equals. you notice you've got all of your y equations here, but also at the top you see plot 1, plot 2, plot 3. If you just scroll up, you're on plot 1 and hit enter. That has now turned plot 1 on. If you needed to turn plot 2 on, you could just scroll over to that. If you want to turn it off, just hit enter. Okay, so we've turned plot 1 on. Great. Now let's graph this and see what happens. I don't see anything. There's nothing here. Why do I? Well, let's think about it. Our points were 0, 1, 2, 3, 4. Okay, well that's 0, 1, 2, 3, 4. That's right here, right? But look at our outputs. 19,000. This isn't 19,000. There's a couple ways we can fix this. One, we can manually do it by going window, changing what these are. But there's an easier way. The easiest way is to go to zoom. And we want to scroll down to what should be option number 9. And that is zoom stat. Remember, to enter our information, we hit stat. So if we do zoom stat, what that does is it automatically adjusts our window to fit the data we've entered. And so we can see here's one of these points here. It's on the on the y-axis. And then it goes all like this. Now, notice how the x-axis I've got clear tick marks, the y-axis big thick bar. The reason for that is it goes from 18,000 to 24,000 with a tick mark every 1. The problem with that is it's trying to put, 6,000 tick marks, essentially, in that little window that we have. So what I want to do to make it a little clearer for myself is I want to go to my Y scale and I want to change it. So like I said, it's trying to put 6,000. So let's just put a tick mark every 1,000. Okay, so the Y SCL, that's the Y scale. So once I do that, I hit graph. And now I can see I've got my tick marks a little easier to read, and it makes this point a lot easier to see. Okay, so we've got that graphed. And if we go back to the step-by-steps, right, to get a scatter plot, second, then Y equals, select a plot by hitting enter and hit enter. While it's on, while on is highlighted, that turns it on. And so you have that all right there. Okay. Now, for this first problem, it wants us to fill in this table, right? So we need to do linear regression, quadratic regression, and exponential regression. And for each one, we need to record the R-squared value. Okay. And the reason why, we can look at this data, right? This doesn't look very linear. It's not too bad, but it's definitely got some curve to it. So right now, I'm looking at this thinking, okay, this might be quadratic or exponential. Okay, again, it'd be curving up, so that would mean our quadratic would have a positive a value, right? Because it's opening up. And if it's an exponential, right, then it is going to be exponential growth. So we want to kind of keep that in our minds and kind of in how to do this and stuff like that. In the future, if you're working through things like this, you could easily kind of go like, okay, I'm not going to do linear regression on this because it's clearly that's not going to be the best one, so let's skip it. But for the purposes of this, I want to do all of them just to kind of show you guys how to do it. So in our steps, so to perform regression, you're going to press stat, then use the arrows to highlight calc, and then choose your desired regression. So we're going to go back to stat. Now notice it puts us under edit. We need to get over to calc. So we're just going to go over to calc. And now depending on what kind of regression you're trying to do, let's see, option 4 is linear regression, and it's giving you the equation in the form of a times x plus b. There's another linear regression later on that gives you the expression in a plus bx, which is the same thing, just different, and it's kind of used in different situations. But we'll use this option here mostly. Then option number 5 is quadratic regression. We have a cubic regression, quartic regression. Here's that other linear regression. ln. What would ln be? ln is our logarithmic regression. Okay, so if we go to our steps and we look down for a logarithmic regression, it is the ln regression, and it is always so the logarithmic is always using the natural log. Now, these words may look similar. They start with the same three letters, but they are different, right? Because the rest of the letters are different, which means they're different words, which means they mean different things. Yet, for some reason, I constantly have students choosing the wrong one. Logarithmic and logistic are different words. We can see here, They are spelt differently. Okay? They are different things. If I tell you to do a logarithmic regression, do not do a logistic regression. Okay? If you need to keep this table, so you go, okay, I need logarithmic regression, that's ln. I need a logistic regression, oh, that's logistic. So it makes it pretty easy. So it shouldn't be a mistake you should make. Okay, if you make the mistake, that means your brain has taken a vacation, right? You need to reel it back in because it's not summer yet. Okay? Keep going down, then there's exponential, there's a power regression, there's logistic, okay, fine, manual fit, and other things. We want to do a linear regression. Now I'm going to do this twice, okay, because we have different calculators have different looks when you do this. So if you have a newer 84, it's going to give you a nice little menu. So when you hit linear regression, it gives you this lovely thing here, okay? What's nice is it defaults L1, L2, frequency list, leave blank, okay? Scroll down till you get to this store regression equation. If we go to our regression steps, this is part 6, okay? So what we want to do, what this is going to do for us, is it's going to store the equation it creates into our y equals menu. And what's really great about that is because then we can look at the graph and see how these look, how they overlap each other, and kind of which one fits best. Okay, this is a really simple process. All right, you're just going to hit the vars button, press the right arrow to get to y vars, hit enter, and then choose what slot you want it in. Okay, so let's do that. So once you're on store regression equation, you're going to hit vars. We need to get to y vars. So vars is short for variables. We want to store this under a y variable, and in particular, we want it to be a function because that's what we're dealing with. So let's do this again. So we choose our regression. Now notice these numbers here. You can use these numbers. So if I want to do linear regression, I can just hit number 4. Okay. This is only if you have this menu here. You're going to scroll down to stored regression equation. Okay. Now vars, over to y vars, hit enter, and now choose the spot. Now if you remember, when we hit y equals, right, we had the top plot 1, plot 2, plot 3, and then we had all our equations. y1 corresponds to that first spot, y2 is the second, and so forth. So like in this problem here, where we're storing linear, quadratic, and exponential, we don't want to store all of them in y1. We want to do one in y1, one in y2, one in y3. That way we can keep all 3 of them. If I put this in y1, and then I go and do regression with, let's say, quadratic regression, and I do that in y1, it's going to erase the linear regression that I have in there and put the quadratic in for me. So we choose the one we want. I want y1, so I hit enter. And we get that. Now then I just go down and hit calculate. And what this did is it calculated the linear regression. Okay, it tells me we did linear regression. And this screen here is you're going to get the same no matter which version you have. You're going to end up with a screen. So you get linear regression. You get y equals ax plus b, where the a value is equal to 1042.1. The b value is equal to 18,754.8. And our r squared value is 0.892. Okay, so this is what information you would record on this table. Okay, now this is the equation, so you wouldn't record just like a equals this, b equals this. You would write 1042.1x plus 18,754.8. Okay, you would create that equation, and our r squared value is 0.892. All right. Now, I'm going to change a mode on here just because it's something that I need to change so that I can get similar to the older calculators. We're going to turn something off there. Okay. So now, if you have an older calculator, like an 83 or maybe an older 84, you're going to go stat. So to do regression, so we're just kind of redoing these regression steps. Still going to do linear. So you're going to go stat, over to calculate, and choose your regression model again for. Now the difference is this time it gives you this. It just puts on your home screen and you're like, wait, where's the menu? That's nice. You have an older calculator, it didn't have that option. It's really simple though. The format of this is the same as the format of that menu where it says, where do you want your x's to come from? Where do you want your y's to come from? What frequency do you want to use? Where do you want to store the equation? If you don't want to change any of those defaults, leave them blank. So if you don't want to say, I want my x's to come from somewhere else, you just leave that blank. Okay, since we want our x's and y's to come from our L1 and L2 respectively, We're going to leave this blank. This is, again, where it kind of behooves you to not change into different lists. But we do want to store our equation. So how do I do that? Well, we do the exact same thing. The difference is we don't have to scroll down to where it says store regression equation. Just from here, okay, we're just going to click vars, go over to yvars, hit enter to choose the function, and we want it under y1. So that our screen should look like this. And let me just hit enter. And it gives us that same output here, right? Now what's cool is if I go to y equals, there's my equation. My plot's still on, there's my equation. So now if I hit graph, there's my points, and that is my linear regression. That's my linear regression line right there. You can see that, yeah, it kind of goes along with it, but it doesn't really follow the shape of the data. So not the best fit. So let's go through and do regression with quadratic and exponential, okay? So we're going to go, again, stat, calculate. We want to choose quadratic regression, which is option 5, okay? Now I want to store this again, so we go vars, over to yvars, and we want to choose a function. Now I don't want to choose y1 for this because that would erase my linear regression. I want to go down and don't want to choose y2. And now I hit enter. And now here, you can see this gives us an equation in the form of y equals ax squared plus bx plus c, where a is 304.9, b is negative 177.6, and c is 19,364.7. Notice I just rounded these all off to one digit. And our r-squared value is 0.999. Okay, that's almost perfect, right? 0.999, that's really good. And again, it has that value here. Now notice it doesn't round these. So if you wanted to have the rounded version in your y equals, okay, you could come through here, click over and highlight where you want to start deleting and use this delete. And that'll just remove one number at a time. And so we go through, delete until we get to the x. Keep going. Now, I don't like to delete right at the edge because it makes it so I can't see what's coming. So I like to kind of move it over like this. So we want to just have 0.6. So then we delete until we get to the x. Now I keep going. Now for this one, because this is a 5, this 6 rounds up to a 7. So what I can do is I can just highlight the 6. Okay, and if I type a 7, it'll erase the 6 and replace it with a 7. And then it moves it over, so I can just start deleting until I get down like that. Okay, and now I've got my equation in there rounded to 1 decimal place. Okay, you can feel free to leave it with all of the decimals in there, that's totally fine, or round it to 1 decimal, whichever works, totally fine. All right, now let's do one more because we need to do exponential regression. So I'm going to turn my stat wizard back on so those people can get another view of what happens. Okay, if you do have the stat wizard, if you get that menu, which we'll see right now, so we need to go to calc. Now, exponential regression was down almost to the bottom. So rather than scrolling all the way down, I can go up. And that just cycles me to the bottom of the list. So exponential regression. So if you have this and you don't want it, you're like, man, the other way was easier. I didn't have to go down. Then you just go to mode. And you want to scroll until you see stat wizards and you just turn that off. Okay, that's all. So exponential regression is 0. X list, L list, X list, Y list are all the same. Frequency list, just keep that blank. It's not something we need to worry about in this class. Store regression equation, we go to the variables. It's a Y variable. It's a function. Y1 was our linear. Y2 was our quadratic. So I want to store this under Y3. And then we go down and calculate. So it gives us our exponential equation in the form of a times b to the x, where a is 18,837.3, b is 1.05, and our r-squared value is 0.905. So if you remember, the linear r-squared value was about 0.8 something, the exponential regression is 0.905, and the quadratic was 0.999. So of those, the quadratic has the best r-squared value. It's the closest to 1. So that doesn't necessarily mean it's the best one we want to choose, but it does mean that that equation fits to our data points the best. Okay. Now you may be like, well, that's what we'd want to choose, right? We'll talk about and we'll see some examples of times we don't want to choose that one. Okay. So I have these all in here. I'm going to go to this one here and I'm going to drop it down to 1. So because this is a 5 or higher, round up to that 2 to a 3. So I go 3, delete, delete, delete. Now, I don't want to round this to 1.1 because that's not the thing. It's kind of too different for me. So I'm going to keep it as the 1.05. It's kind of something that, I mean, there's really no hard science to kind of how far to keep that out to or what to do with that. I usually don't like to delete a 0, change a 0 away. I like to keep that if it's there. So I've got all this in. I just hit graph and I see the order that I graphed it. So it graphed our linear equation first, our quadratic second, and then our exponential, which almost went on top of our linear, third. So we can look at this, we can clearly see that the quadratic fits our problem best. And now when I said earlier, like, well, that's not always what you want to look for, is just the r squared value, which clearly here the r squared value is significantly higher than the others, or significantly better. Some other things you want to take into account are the nature of the problem, the nature of the situation. Okay, we'll see an example here where it wouldn't make sense to use a quadratic because a quadratic goes down and then back up, or up and then back down. It would make more sense to use an exponential or a logistic or a logarithmic. I mean, and there'll be times when you'll get two equations that have really similar r squared values. Maybe even one's a little bit higher than the other. But think about quadratic to linear. The difference between a quadratic function and a linear function is that x squared term. But what if the quadratic, when you do quadratic regression, you're saying, calculator, give me a quadratic equation that works for this. Well, the quadratic equation that works for that may have an a value of like 0.0009. So basically what it's doing is saying, okay, take this x squared term and make it as small and insignificant as possible so it doesn't really matter, and then use the other term. So it's just giving you a linear function with a little tweak on it. And so it'd be better to choose a linear example in that case. We're going to do two more examples where we're going to see this happen, and so I can kind of point that out to you. But here, there's nothing else that's happening. These equations are very different. There's clearly a quadratic piece here. It's not kind of, basically linear. Like the exponential and linear are basically the same. So if those were the best fitting ones, I would personally choose the linear function, because looking at this, the two equations are so similar or the two graphs are so similar that I would much rather work with a linear equation than a quadratic, or than an exponential. So there we have it. Now, here's a really cool thing. So remember, it said that the next thing was to use that function to answer the questions. This is just doing steps that you have done in the class already. Okay? The only new thing in this whole section is finding the equation. Previously, I've said, hey, this equation models the height of the ball as you throw it in the air. Now find these things. Now I'm saying, here's heights of the ball at different times. Give me the equation that models the height of the ball, and then find those things. So to estimate the average tons in 2000 and 2005, there's two things we have to do first. One is figure out how many years since 1990 are they, so that we can use the correct input. So 2000 is 10 years since 1990, 2005 is 15 years. So pretty easy. Then we just have to, since those are inputs, we just have to plug those into our equation. We decided the quadratic fits best. So what's really cool is if you want to avoid confusion, you can, or you can just leave it all in there. So what I'm going to do is I'm going to clear these out. So I want to clear that one, and I want to clear that one. I'm leaving my quadratic in there because that's the one I want to use. Now, I want to go to my table. So I hit second and graph. Now, depending on which you've set up, I haven't changed this on this calculator here, so I'm going to change that real quick. So if I go to second and then window to get to the table setup, okay, what I want to do is I want to take it down to independent and ask. I believe I talked about this earlier in the term. Now we're seeing it there in person. And now by doing that, when I go to my table, my x values are blank because I can input whatever I want. So I want 10 and I want 15. And we can see that when we do that, so then the output, So if I highlight that, is this. So in the year 2000, okay, our equation estimates there will be 48,078.7 tons or thousands of tons of garbage. Okay, we can do the same thing down here, and we get those values. Okay, so that's problem one. Let's move on to problem two. Let's do problem three. This is a fun one. So here we have this little problem. This may sound made up and fake, but it's actually real. This is actually something that's really cool. This is some actual data, some real things. So, biologists observed that the chirping rate of a certain species of crickets appears to be related to the temperature. What would the chirping rate be at 100 degrees, round to the nearest chirp? What temperature would it be if the chirping rate was 0, round to the nearest degree? So, we have our data here, 50, 55, 60, 65, 70, 75, 80, 85, 90, and then our chirp rates. So we go from 50 to 90. So we need to enter our data. We go to stat, and we hit enter. Remember, if you forget that, regression steps. Okay. To enter data, press stat, and then enter. Okay. So I have all of these in here. Now what's really nice is I can just rewrite them. I don't have to erase them. I can just write over the top of them. So this isn't years, so I'm not going to say like, oh, this is 0, 5, 10, 15. No, this is 50 degrees because 50 degrees actually matters. There's a significance to it being 50 degrees versus 0 degrees. Whereas if we go back to problem one, there's no significance in this being 1990 or 1990 versus it being 0. There's no difference, right? It's just about a time, okay? So let's do this. I'm going to use my computer because it's much faster to type. So you type the number, hit enter. $70, $75, $80, $85. Okay. All right. My screen has decided. There we go. Okay. This is what happens when you get an emulator, not an actual calculator on your computer. So there we go. I got my numbers in. Now I need to get my outputs. So 24.6. About all my things typed in there. Ooh. I'm looking at it going, cool, okay. Oh, wait, what's going on there? Huh, I typed 19, not 198. I caught it here because there's a nice easy gap. But let's say I didn't catch that yet. Let's look at what would happen and see if anything looks weird. So the next thing I want to do is create the scatter plot. This is always an important step. I notice my lines are equal, so I'm good. Maybe I didn't even look at my data, right? So I go, cool. Y equals, I don't need this anymore, so I can clear that out. My plot one is on, so I hit graph. Wait, why don't I have anything? That's right, because I entered new data, so I need to zoom, and I need to choose option number 9, zoom stat. Every time you change the data and you want to see the new scatter plot, always zoom stat. What the heck? What's going on here? Well, we can see there's something going on. There's something wrong. So what I want to do is I want to go back to my data. I want to look at what I did. Oh, I typed 19, not 198. Now I can zoom stat again. Better. Everything's good now. That looks much more in line. So if you ever get a really wonky point, just like a single point that's just way off the path and doesn't look right at all, most likely you just mistyped something, okay? Now, real quick, I want to come back here and I want to show you another common error, right? Let me let's delete this one. Okay. Let's say I accidentally doubled something up or whatever, and so I don't have an even list. Okay. Well, now when I go to graph, it's going to tell me dimensions mismatch, dim mismatch. That's saying is the dimensions in your list are not the same. So I need to go back and I can see, oh yeah, clearly those aren't the same. I need to add in 90. There they are. Okay, perfect. So now let's do our 3 forms of regression. So this problem again, or this one actually has a 4th logarithmic. So let's do our 4 regressions, staving our 4 equations into our thing. So stat, calculate, we want linear regression option 4. Just store this required variables, y variables, choose function. I want this to go into y1. There you go, r squared, 0.998. Okay, there's our equation. You guys will write these down however you go. Let's do quadratic regression. Store equation as bars, y bars, option 2. There we go, r squared 0.998. Ooh, those are the same. What's going on? Now, one thing I want to point out here. What's our a value? Think about it. What is a? It's not 9. Because look down here at the end. See this? This is scientific notation in your calculator. So what this tells you to do is it says e negative 4. So that means this is like saying this times 10 to the negative 4th. So this means I need to move this decimal place 4 places to the left. So it gives me actually, so my a value is 0.0009. Okay, so my a value is 0009. 0009. Yeah. That's really small. And remember, that's the piece with that x squared. So what's going on here? Let's, real quick, before we move on to anything else, let's look at these. So with the linear, my a value, the number times x was 4.98. Okay? Let's do that. So it's a little easier to see. Okay? And leave that there. In the quadratic, the term times the a value, or sorry, the x value, not the x squared, but the x, we'll keep an extra decimal place just to be safe. It's 4.85. This is 4.98. This is 4.85. Well, what about the constant? Well, my linear, it's negative 229.03. Okay, so negative 229.03. What is it in my quadratic? Negative 224.7. So those are pretty similar numbers. If I hit graph, it's a linear, quadratic was like right on top of it. So this is a situation where both of these 2 equations have an r squared value of 0.998. Really good fits. But the quadratic function has the quadratic term, that x squared term, has a coefficient, that a value of 0.0009. It's basically saying, okay, cool. A quadratic doesn't fit this, so let me kind of delete this quadratic term as best as I mathematically can and make it linear because it's a linear situation. And that's what's happening. Okay, so this would be a situation where they both have the same r squared value, but the linear function is a much better fit. And by looking at the scattergram of this, the scatter plot, it's obvious that that is a much better fit. And so we want to make sure that we take our time and actually create the scatter plots of these so that we can identify what type of a function needs to be used. Okay, awesome. Now, for practice, I'm going to switch over so that those without the stat wizard can see what I'm doing. And we're going to do exponential and logarithmic, even though we kind of already know what this is going to be. So exponential is 0. I want to store this under bars, y bars, functions, and this is my linear, this is my quadratic, so I want to choose option 3 for my exponential, and hit enter. Here's my next one. It's our squared value is 0.899. It's not bad, but not 0.998. So let's do one more. Again, these are the things you'd be writing these down. If you had this actual activity in front of you, you'd be writing them down in here and working with them. For this video, I'm just kind of doing these steps. So natural log is what we want. I want to store this equation under the variable, y variable, a function. This is my linear, this is my quadratic, this is my exponential. So I want to do this one here for my logarithmic. So option 4, I do it. And see, this gives me the equation in the form of a plus b times the natural log of x. Here's my a, here's my b. Ooh, this one has an r-squared value of 0.990. That's better, right? That's pretty good. But again, that's not as good as 0.998. So still those linear and quadratic definitely fit best, but the exponential and logarithmic are too far behind. So we see linear, there's quadratic, there's exponential, there's logarithmic. Now on here, it processes those pretty quick. On your calculator, there's a little bit of a slower uptake, so you can kind of see those tracking a little easier. Like the quadratic and linear, when they track right on top of each other, it's sometimes hard to see. But if you just see all one line, you can understand, you can kind of make the safe assumption that, okay, both my equations are the same exact, basically, graph, at least within this window. So looking at all this, I can see that, okay, obviously the best fit is linear. So I can come in here and I'm going to clear out the quadratic, clear out my exponential, and clear out my logarithmic, leave me with just this, because I need to answer the questions. What would the chirping rate be at 100 degrees? Okay, so I can go to the table and I can type 100. The chirp rate at 100 degrees would be 268.97. Now it says to round to the nearest chirp, so that'd be 269 chirps. Pretty easy. Now the next question says, at what temperature would it be if the chirp rate was 0? Now you may be like, oh, I know, I'll come over here and I'll be like independent to auto, dependent to ask, and then I'll be like, yeah, I got this. And I come over here and I go like, well, what if this is 0? 0, 0. Why is it not giving me 0? It's because for some reason it doesn't work that way. I don't know if there is a way to make that work. If there is, I don't know it. Maybe if I do this, maybe I have to ask them both. Over here, 0, 0, 0, 0, 0, 0. Nope, doesn't work. Now, one thing you could do, and this wouldn't be a bad thing, it just wouldn't be a very efficient thing, is with it set up this way, you could go, okay, well, I know at 50, there's about 20 chirps, right? We can look at our table. So let's go down from there. What if I do 45 degrees? That's -4. So, okay, somewhere in there. So what about 46? There we go. Okay, so 46 degrees is the answer. That's not a bad way to do it. This was pretty lucky. We got some pretty nice, easy numbers to work with, but sometimes it's not as quick and easy, and you don't necessarily know if it's that quick. This is a linear equation. 4.98x plus negative 229.03. Just set that equal to 0 and solve it. You're going to add the 229, so you're going to end up with 229.03 divided by the 4.98 divided by 4.98. 45.98999, rounding to the nearest degree, 46. And you're like, well, we just found that on the table. That was so much easier. This is a little bit simpler. You don't have to do so much guessing and checking. Again, if your numbers are a little more wide, right, that jumped quickly from what we knew at 50 down to 45. It was a pretty quick, easy guessing game. but sometimes it's not. And especially if you have like quadratics or exponentials, it's going to be much easier just to solve the equation the way you would do it mathematically. If you're not sure how I got to here, just take this linear equation, set it equal to 0, and solve for x, and you'll see it. All right, so there's one more I want to do. Clear that out. Go to stat. Go to edit. I'm going to clear list 1. I'm going to clear list 2. And what I want to do with you guys is problem number 5. So this is an art class where students are tested at the end of the course on a final exam. They're then retested with the equivalent test at subsequent time intervals. So I say equivalent test, so it's not the exact same test, so people aren't memorizing the answers, but it's kind of the same exact material covered. Their scores after time t in months are given in the table. Use the regression model to predict test scores after 8, 10, 24, and 36 months. After how long, if ever, will the test scores fall below 82%? So there's a couple of things going on here. One, our inputs are time, but notice it's the number of months that have passed. So we wouldn't want to reset this down to like 0 or anything like that. It's not like an arbitrary year. And so we'd want to keep it like this. The other thing is the outputs are in percents. Now, one thing that I have said, and you've probably heard in other things, we don't do math with percents, we convert them to decimals. You could do that here, but because we're talking about outputs of a function, the output of a function could be representative of a decimal. In other words, when a function gives you the output could be 84.9. You go, okay, that means 84.9%. However, if you were to convert these decimal points into, or these percents into decimals, then the function's output would be 0.849, and you would have to convert that back to a percent. So in a situation like this, because we're not actually doing math with the percents, that's just our output is in a percentage. Just like if an output was in dollars, right? We wouldn't change that to cents. You could leave it as the percent. So I'm going to leave my data exactly as it is. I'm not going to enter percent in the calculator, but the numbers are going to keep the exact same. So 1 through 6 are my inputs. 1, 2, 3, 4, 6. Okay. That's all good. 1, 2, 3, 4, 5, 6. I didn't mistype anything. Here, 84.9, 84.6. Enter. And much easier if you have this in front of you, not on a separate screen. 84.4, 84.2. 2. And 84.1, 83.9. Okay, got my data. So the first thing we want to do, that's right, zoom, option number 9 for zoom stat. There's my data. Okay, kind of linear, maybe a little bit of a curve to it. Yeah, I mean, I can kind of see a little bit of a curve going on here. Then this kind of throws it off. If this is up a little higher, it'd work, right? We can kind of see, okay, maybe what's going on. So it's not super obvious on this one what's going on. So we want to do our regressions. So we do our linear regression. I want to store that. Option 1. In our square root 0.979. That's pretty good. There's my equation. Again, you guys are going to write these things down. Now, one thing I want to point out, linear regression gives you an R value. Now, why does this give you an R value and none of the other ones do, but they all give you an R squared? That they all give you an R squared, they must all have an R, right? The R value in a linear regression is corresponding to, it ranges from -1 to 1. And if it's closest to 1, that means there's a positive correlation between these points. In other words, they are positively sloped. Whereas, I didn't positively slope for you guys with that. Whereas if it's close to -1, that means there's a negative correlation. In other words, there's a negative slope. Okay, but R squared is general to all different functions because we all know that other functions don't have slopes, and so we use the R squared value, not the R value. Okay, so there's linear. Let's do quadratic. Okay, the quadratic is still there. Sorry, vars, y vars, function. Y1 is my linear, so I want to choose option Y2. And here my R-squared is 0.9937, so that's better. So right now quadratic is winning. Calculate exponential is 0. Y bars, function, option 3. R-squared 0.979, so it's a little worse. Stat, calculate. So here 9 is logarithmic. Y bars, functions, on option 4. And R-squared is 0.982. So they're all pretty good, right? If I hit graph, we can see the linear, there's the quadratic, the exponential, basically right on top of the quadratic, and then the logarithmic. So I want to isolate, because the linear was good, but not great. So, and same with the logarithmic. So I'm going to get rid of those two. So Y1 was my logarithmic. Y4 was my, Y1 was my linear, Y4 was my logarithmic. So I'm left with these. These are pretty close. They had really similar R-squared values. Now, the problem here is what happens in the long run. So let me take my window. And this isn't something that you guys would necessarily do. This is something I'm going to do to show kind of an emphasize the point. And right now our max X is 6.5. So that's like 6.5 months out. Let's take this out to 36 months. Okay. I'm going to set this up a little bigger so I don't have a big thick bar and graph. Well, we can't really see what's going on with one of them. So let's, my Y minimum, these are percents, right? So my Y min, let's just say it goes down to 0%. I don't need these scales at 1,000. So when you do a zoom stat, it doesn't change your scale. It only changes your X min max and your Y min max. So if I'm going like that, let's do 10. Graph. That's not very nice. So let's do our min to 70. That's the thing. When we're doing window changes like this, you're just kind of guessing and hoping you get things that work. All right. So I can see that these equations look very different. They do very different things. Okay, let's jump this about half. I'm trying to get this to fit nicely for us. So 36, let's do 20, and instead of 70, let's do 80. There we go. Okay, now we can see a good picture. So we can see what's going on here. This is saying these decrease, and this is, and it looks very linear, but that's just because we're looking at a small portion. This says they decrease and then go back up. Which one would be a better fit? Now think about this. What was this problem about? This problem was about test scores months after you took the class. So do you guys think, let's use this class for example. If I give you a final, which I'm going to, so be ready. I give you a final, you take it, and then a month later I give you another similar final, and then a month later I give you another one, and another one, and another one. Do you think your test scores are going to go down for a while, and then they're going to go all of a sudden come back up? No. Right? They're going to keep going down until you get to a point. There's going to be some point. Let's take our window. I'm going to take my X out to, let's just say 100. Take my Y minimum to 0. You see, this kind of has this leveling off, right? Which makes sense, and it's going to happen at and so it makes more sense that our scores are going to eventually kind of flatten out because there's some set of information that we just know, right? After this class, you're probably going to be pretty good at solving linear equations. So on the test, you're always going to get those linear problems, right? So it's not necessarily going to go down to 0, but you're always going to have some knowledge there. So it makes more sense that this is going to kind of come down and go and isolate and kind of level off like a exponential function does that's been shifted. But a quadratic, it doesn't make any sense that my test scores are going to go down and then come back up. That doesn't make any sense at all. So make sure you guys take into context the situation that's happening, right? So our best fit here would be the exponential or maybe even the logarithmic, depends on how you feel. Okay, so that's it for this lovely lesson on regression. I would recommend going through and doing some of these, okay, getting a feel for this, using this data set. Make sure you know this, make sure you have this. This wouldn't be a bad thing to have with you on any tests that you have to do, because I guarantee you on your final you will have some regression. So make sure you have this so that you don't choose the wrong form or you don't forget how to do these. In a normal in-person test, I would not let you have this, because if you had a question like, oh man, how do I do regression? My calculator, I forgot, I would just have you ask me and I could tell you. But so make sure you have this so you know what to do. Okay. Make sure you identify clearly what your steps are, what you have to do specifically. And then go crush the homework. Okay. So there's 8 questions. Not too bad. Okay. Now some of these are going to ask you to give the actual equation, rounding. So this one doesn't. Let me find what it does so we can talk about this. Here we go. Gives the equation. So if it specifies, say, use 3 decimals in your answer, use 3 decimals. Don't use 4. Don't use all of them. If it doesn't specify, I think there's 1 or 2 problems. I may have gotten rid of them. So like this one doesn't specify. I think the best bet for you is going to be to keep all of your data, all of those points. So whatever your calculator gives all of those values. I know it's annoying. It's just a coding thing in here. It's a pain to change. So I'm just making you guys deal with a little bit more pain than I want to. So that's it, guys. I hope you enjoyed this. There's one more lesson for most of you guys on matrices. If you're in the Bolt class, this is it. If you're not in the Bolt class Spring 2020, you got one more lesson on matrices. If you're in a regular class, we have 2 lessons, one on matrices, one on sequences and series. So keeping you on your toes, check that calendar, know what's happening, know what's coming up, and I'll see you guys around.